It feels that way, but you know what? A lot of these conversations, the way they're happening, I think that's just the nature of it because it's like a it's like a deep tea, right? Like you have to talk about some things up here,
Hmm.
dive deep, come back up, and talk
Yeah.
about it up here. Um, we talk a lot about coding and programming, but that's not necessarily what we need to understand actually, because that's been outsourced to an AI,
Yeah.
outsourced to a data center,
Hmm.
outsourced to a server that can do the coding and programming. So what's there left to do talk about as far as what's deep? I think I think digital twin is a perfect example of how deep this conversation can go.
Yeah, I think so. Yeah, but it would help to kind of talk about what a digital twin is and isn't,
Yeah,
because it's one of
and
those
yeah, and I
it's one of
won't
those
risk
things
that.
that's gotten
I won't
murky.
risk that on my side. I'll let you do it.
Yeah, sure. So I think the definition of digital twin has gotten a little bit murky because it's going back and forth between lots of different industries and used in so many different ways. So what I say digital twin is to one industry means something completely different to another, right? So uh, if you're in construction, you might say, well, digital twin means I need, geo data around where I am to get a sense of where this building is in the world or something like that. Or some people might say they make digital twins when all they're making is a 3D model. So it goes from a very small digital twin of just a 3D model to some overarching thing of where you've got geo data, you've got sensor data, you've got 3D models, and you might even have immersive tech in there somewhere. So I think what we're talking about when we're talking about a digital twin is that bigger picture kind of digital twin where it's a visual representation of real time data in some way, whether that is a 3D model or if it's something web or if it's just your kind of basic dashboard. But it's something that is telling you exactly what's happening with your asset out in the real world in some digital format. I think that's a good enough definition of it.
Yeah, yeah. I mean, you hit on that point, immersive, right? When you say immersive, people just settles in right away. They're just like, okay, all right. It's not that complicated. We're so used to digital twin, like you said, different places will call it different things. I think at one point he said this is just a video game, and when you say video game, people click right away. Oh, digital twin, like an avatar, like so many things that we're so accustomed to. But digital twin is a murky term, right? And I think when me and you were discussing it, I said that if there's a sensor and that sensor is being replicated in the digital world, that's just a computer assisted designing, right? Like I
Mhm.
can make a copy of the way my cell phone works inside of a computer.
Yeah,
But if I can run my cell phone from my computer, as in click on a few things, and all of a sudden what's happening in my laptop monitor is also what's happening in my phone, all of a sudden there's a feedback loop that is initiated and things are actually running in my phone just the way I'll be touching it actually.
yeah. So the two-way
That's that
communication.
digital twin environment for me, you know?
Yeah, that's true. That's a better way of describing the sensor data input output, and there's a
Yeah.
two-way communication between
Yeah.
the digital twin and the physical asset, whatever that may be, whether it's
Anything physical
yeah,
asset. If you can start with a clay sculpture and want to 3D print it, or you want to 3D scan it, whatever the case is, and put it inside of a computer, all of a sudden you're able to do funny things with it, right? It's all of a
hmm
sudden it's a digital twin. But the spectrum is so wide, right? So customer border patrol, sorry, customs agent, that's what it's called, customs agent. You walk up to them, you show them your passport, and the person looks through all the information on the computer and says, "You're good to go," right? Well, if that customs agent was a digital twin system that mimics like a customs agent, that's also digital twin, right? It's actually having real time feedback and interactions. So digital twin, I think, in your aviation industry, It's pretty much famous for engines, how the engines will interact with the environment 30,000 feet above the air. But 30,000 feet above the air is not the same everywhere in the world. So if it's flying over Tibet, you will need to know the difference in altitudes and what happens there, right? The variables. Um, I think a lot of people can conceptualize that. So that's kind of like the what of digital twin, Of course, we have to talk about how and why of it, because I think you also mentioned that it's murky. The terms are kind of elusive. Um, some people call it virtual prototyping. Some
Mhm.
people insist on calling it just CAD, EAD, whatever the case is, and they stick to it, right? Because that's how they've been informed about this for 30 some years now. But digital
Yeah,
itself is about that old at this point because that's how we've been doing it.
that's true. But I think kind of our new iteration of what people now call digital twin is has kind of taken that to the next step where we have things like immersive tech, things like XR, VR, AR,
Yeah.
where you might not necessarily just be looking at the digital part of the digital twin
Yeah.
uh, just on a screen. You can be in the room with it virtually as there's some physical asset over there that you're monitoring, right? So, like you said, with an engine, you might have an engineer in their house, and they can just put on some VR goggles and they can walk around it, manipulate it manually as if they were there, and see this prototype that is acting exactly as it should based on the physical prototype you have somewhere that might be getting sensor data for temperature. Uh, I don't know what else would you care about with an engine. The actual
Actually, the
physical,
rotation of the
yeah,
blade
exactly,
maintenance of it, how fast it wears out.
yeah,
Yeah.
yeah. Aircraft maintenance is a huge user of digital twin, right? Because you're talking about these. You might just build out this one prototype, but then 200 engineers across the globe could be looking at it, commenting on it. You could even put little notes on the digital twin that everyone else's digital twin is going to show up with in real time,
Yeah.
and just be able to prototype it that way and save a bunch of money
Yeah.
and a bunch of time.
I just had a funny thought in my head, like you're walking around aircraft parts, and all of a sudden you bump your head, but at home the engineer's bumping their head into the notes that's popping up on top of their head.
Oh, someone had this to say, and just sort of
Wait,
jumps
there's a
out
yellow
at you.
notepad over there.
Yeah. Which,
Uh, like people are using goggles these days, VR goggles, and so when you say immersive, that's the first thing that people think of, but it's augmented reality, MR, mixed reality. Uh, so if you have a device that can do measurement, so I always use iPhone as AR example because that's
yeah,
literally what people are very familiar with, or no, any phone actually, not just iPhone. um, you have augmented reality just through your
yeah,
screen. You don't have to actually put it on. The reason VR is so popular is a very narrow use case. All of a sudden, you go to AR, it becomes a wider use case. Because if you have a phone, all of a sudden you don't need the VR anymore, but you cannot do certain things that VR can do with AR. And then all of a sudden, if you cannot do immersive, what's the point of even doing this? Like, say, for example, training to teach somebody what an engine looks like, how to take that engine apart without taking that engine apart, how to reduce the cost of training so that way people are able to do just-in-time training, on-demand training. So the use cases expands and shrinks depending on who it is you're talking to, but VR is definitely limited to a certain point, right? You can't do everything with VR. But with AR, there's a use cases. Some of the ARs you just cannot do immersive with AR, right? Um, Unless you really spent that money to buy all the screens around you or holograms and the
yeah, even
projectors that goes
Dell
with.
projectors, yeah, all
Yeah,
that stuff.
more we talk about these AR, VR. One things that is really becoming popular is going back in days of the CAD, computer assisted designing or electronic assisted designing, the data centers. Right? I think that's what me and you kind of said. Like, that's the use case that really will save tons of money, because the amount of data centers that is coming in online these days, they're opening them up really, really fast. And they're opening them thinking like, we will have electricity for next 100 years. Who knows? Maybe we'll run out of electricity unless we find a good way to produce it.
Yeah, that's a whole different discussion.
A whole different discussion. But what if there's a digital twin in the middle to help us guide through the process, so that way we're cutting down on the time and wasted energy, right?
Yeah, for
Consume the
something
energy,
like,
save the energy.
okay. Yeah, so when you're talking about something like a data center, the digital twin can be sort of an end-to-end solution, right? To where you need to construct the actual building, you need to build your data center, and a digital twin can certainly help extradite that to where you are able to preview what this thing might look like, where you're going to build it, all using immersive tech, things like Unreal 5, where you can build a 3D model of it in an actual physically accurate geolocation where it's going to look like where it is in the real world. You can preview everything about it, walk around it. Someone might have made an architectural CAD model where you can say, all right, well, I like our building, but let's like rotate it a little bit to the left so that the sun's not in my eye, or something like that, where you can get like a totally accurate representation of the physical conditions of where you're going to build this thing.
Yeah.
And then you move on to the next step where you built it. You can have a digital twin of the actual data center operations, where you can look at it and say, okay, these servers are running optimally or not through some sort of dashboard. And whether or not that's represented in 3D is kind of up to you. But it can also be involved in things like training the techs who work on the data center, using that same model we used to help build the physical data center. Oh, I already have that model because I, built this architectural model. Now someone can walk around this physical data center. We can teach them how to fix the servers and how to set up new servers, et cetera, in the actual environment.
Yeah, I think when you say end to end, it goes beyond, to me, like the life cycle. Let's say, for example, every big project has multiple life cycles inside of it, whatever the case is, and keeping up with it requires a lot of these endpoints, sensors, or lots of these people, process, and technology effort. But digital twin can capture all of it. I think that's the one benefit of digital twin, that you can stack it as much as you like and get the visualization that you need, but in a way that you can share with everybody. So a lot of the problems that I've seen in business intelligence world is that there's 5 guys who gets all the reports. Nobody else has access to it. But if you give it to 500 other people, they would have been able to make decisions right away, because they're not waiting for those 5 guys to see those reports and creating a process of making decisions.
Yeah, exactly. So, and you can create it in a form that anyone can understand, right?
Anybody, that's a big part of it.
Yeah. Instead of giving someone a report full of jargon that maybe not everyone is down with, you can show someone physically, like, here's the dimensions. You can even saying dimensions to someone, they might go like, yeah, that sounds big, I guess. But if you can get someone in there, whether it's in a headset or on a screen or even just with their phone, right? You can get a pretty convincing sense of scale just through the AR on your phone. And you can actually see this space, walk around the space, and comment anything you want on it, way beyond just words on a page.
That's right. Yeah, so one of the things that a lot of people ask questions about, like, why am I building a data center? What's going on with the data centers? Why are there so much investment in data centers? So of course, the most recent one is $500 billion in Stargate. Everybody's talking about it. People think $500 billion and don't think much of it because the numbers just get thrown around these days with billions so easily.
Mhm.
$500 billion is what Department of Defense gets every year, which is close to $900 billion. So if you're thinking about the spending in a data center, and that's how much we're spending on data centers, which is the defense budget is $800 billion. That's how much we spend on almost every uh, uh, financial year, right?
Yeah. Wow. That really puts it in perspective, huh?
Right. It's pretty big.
And that's
Yeah.
always the side of the budget that everyone complains about.
Right. It's massive, and it's
Yeah.
coming from private sector on
Mhm.
top of that, right? The government is not funding it.
Yeah.
So the reason I say that, when you hear something of this massive scale, how do you get the investors to buy in without seeing the plot of land, without seeing the return on investment, without really seeing all things physical? But all of a sudden, if you have digital twin of other data centers, and you can say, I see a pond over there, and right next to that pond, there should be a data center. Create that architecture for me. So give me 30 minutes. I'll come back to you and give you an architecture of what a data center would look like next to that pond.
Yeah. Not
Give me
even,
the
yeah.
geolocation, how many miles and square inches of spaces you have. We'll create that digital twin based off of all the other digital twins. That's just to get the buy-ins from the investors. Now think about commercialization of it. Like, is it marketing that piece to the public, saying this is how the data center will look like, and these are all the businesses that will come next to the data center. Now these are all digital twins still. But here's the difference. Because of NVIDIA, because of ChatGPT, because of large language model, because of all these AI capabilities, all you have to do is type that into your screen saying, there's a pond, as you can see on this real satellite image, put a data center next to it. So when I say 30 minutes, I'm actually articulating the fact that I'm going to go into a computer, type in on a large language model, this is what I want to see. And all of a sudden, these things are happening on my screen. I don't have to do drag and drop. If I did drag and drop, probably would be 3 or 4 hours just to create one data center. But
Oh,
within
yeah.
30 minutes, I can create the data center up to a standard, create all the businesses, all the roads that will lead into the data center, all the things that activity will change, right? Shift in traffic patterns in your I-35, whatever the case is, right? And this happens right away. You don't have to go through architectural process of next 6 months. By the time you take it to the commissioners and say, "Can we get approval on this one? Where's the paperwork?" "Oh, I have it right here. Look at this YouTube video." This is
Yeah.
what I
Or even
want
I have it right here, put on this headset, or
to put on the headset.
yeah, you can
Walk
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 around it.
around it.
Yeah. No, and you said 30 minutes. I mean, when I was working with Lidos, we we had it where it was instant, right? Where they were siting air traffic towers, and they would say, well, we don't really like this site. There's some such environmental issue there where we can't build, and now we're too close to it. We need to be 50 feet that way.
Right.
I mean, it's instant, right? We can just type in a new coordinate and we can put you right there because we're using a real-time game engine.
Yeah.
We're taking that game tech and rendering things in real time, 90 frames a second, straight to your headset.
Yeah.
So even when you said 30 minutes, it
That's
might
a
not
lot.
even be that.
Right.
So
Right.
depending on if you're doing, how deep those simulations go, it might not even be that. It could be instant, right? I could
Yeah.
be sitting at my desk in Dallas. You're somewhere in, Virginia,
Right.
and I can say, all right, well, I'll just put you there, type a couple of things, and there you are.
And that's the connection that a lot of people sees, because a lot of people are familiar with that, right? The fact that you can take an IP address, sorry, not IP address, but grid coordinates on the geospatial map and do all sorts of things with it, right?
Yeah.
But how fast? How do you use large language model? How do you use AI? What's the relationship between AI and digital twin, right? Why do you have to do digital twin 10 years ago? And why do you have to do it today, specifically because of AI? There's a whole lot of unpacking to do because now that digital twin is far more powerful. Because
Oh
what
yeah.
you are able to do in a few minutes, uh, it requires that you have years of experience, right? So your people that will engage with the digital twin, they will have to incorporate AI into the mix because of the reference model that you have to pull, right? Because the digital twins has been very powerful, but it's even more powerful because of NVIDIA's USD, right? Universal Scene Designer. It's literally rendering pixel-like quality of things that doesn't even exist. All of a sudden, you can make Toy Stories just by using a few prompts,
Yeah.
right? ChatGPT style. I can go on and on and on, but these are all based on AI's ability to render, AI's ability to figure things out off of previous communication. So Florida has gators, Texas doesn't. Should you recommend me building a data centers in Texas versus Florida, right? Because Florida might have something hurricane, right?
Yeah.
Texas
Yeah.
might have something this, you know. Um, I'll just leave it at that. But
Yeah.
it's
That's
the
an
AI
interesting
connections
angle.
that I want to make, connect the dots here.
Yeah. I think what you brought up is an interesting element too, right? Where your large language model, your chat GPT like
Yeah.
can comment as well on what it knows about that area, to where I say, okay, here's some geo coordinates, uh, put my digital twin there, and it might say something like, oh, based on data I have on this area, this is some sort of environmentally protected spot here. There's some endangered birds, so you're not allowed to cut down this
Yeah.
part of the forest or something.
Yeah.
uh, give you that kind of data in a very easily consumable way, right? You're not reading through a bunch of reports. You're just getting a straight answer of, hey, can I build this building of this size in this area without any issues?
Yeah.
And then you'll get a straight answer. And also, enhancing the visuals with generative AI has been something that a lot of folks are kind of chasing that holy grail of filling in a lot of gaps that now, frankly, have to be done manually, with a lot of things like cesium, where you get accurate data of the area visually, but not all of it's 3D. Some of it's outdated.
Yeah.
You won't get real time lighting on buildings and things.
Right.
But there are some companies out there, like Black Shark, um, who have a whole system where it's not just the landscape data, not just the building data, but it's also filling in those gaps that it might not have with things like lights, uh, down to a point where all the individual taxiway lights on a runway would be there.
Yeah.
So you could land your plane. And that was something that people had to manually place those to create an accurate digital twin. And now it's just, a few prompts, a few clicks, and there you are.
Yeah.
It's really taking it to the next level.
Yeah. I think the power that you bring to this discussion here is that you can say how to get to the shortcut because you've been doing it for so long. And the reason people really need to focus on this is because if they haven't been talking about digital twin, they might get they might get myopic vision over and over. Like they might get this tunnel vision about digital twin over and over. And I think that's what I've been battling with for a very long time. Is always talking about the fact that there's a forest of AIs out there. You're missing it for a tree, right? Don't miss the forest for a tree. And
Mhm.
that tree is large language model. But the large language model is sort of the gateway into that digital twin space, right? If you can think about it from digital, if you can do it with the large language model, you should be doing it yesterday. Some of the other things that you cannot fix, maybe large language model cannot fix it either. But if the large language model can fix it, go for it. Because
Yeah.
large language model can create those augmentations that you need on a picture that's not really well pixelated.
Mhm.
So, a large language model can take a command like you recreate using Gen AI, recreate that image, and start plugging in the fence line of an airstrip and say, yeah, there's a fence over there. You should have that visualization as well because the picture comes from a night and it's very blurry, right?
Mhm.
How far is that fence line? How far does the aircraft actually crash, right? So this is the digital twin capabilities. But I think you mentioned something about just reporting and seeing things on a bar charts or a pie chart, right, or a graph. That's been another opening of conversations to say this is not about a physical space only. This is about process as well, because there's a business intelligence component to it that is far beyond just images, right? So again, going into the large language model discussion, what if you could envision what happens throughout the day in your store, like say for example, on Auntie Annie's, right? What example can I pick? Let's
Okay.
pick the Baskins and Robbins, right? Like how many people were in the line, what happened in the line, what was the customer satisfaction like, what was the customer's interaction look like, right? In real time, you're able to gather those feedback and review them later and say, yeah, I think something we have to adjust here, right? The price of that cone, maybe, or price of this flavor, something has to change. So this processes that we will previously would say, well, that will require a lot of human hours. Now you can take that process and say, I have a security camera. How can I use the security camera to create a digital twin of the stores that I'm monitoring, right? And that's a single sensor hardware that you can turn into your digital twin sensors, and it's actually providing reports at first, but it's actually providing insights in real time. The security camera can also provide early detection mechanism of to say, the mall just got kind of crazy, wacky busy. There might be more customers coming in. We don't know how hot it is outside, but now that we're tracking how hot it is using a security camera, all of a sudden we can articulate the demand signal going up per hour, right? We do that in business intelligence, say, oh, Arizona's always hot. It's going to be always hot. They're going to have no problems getting customers. But at this point in the at this geolocation in the country, the demand is not that steady, right? So you have all sorts of ways that process can be improved with digital twin, but right now we have to rely on a dashboard, and we are mastering the dashboard. Like
Oh yeah.
you can just imagine how many mushroom-like tools out there there's for dashboard. So you can see one more bar at the end of the bars, right? These capabilities of reference model, these dashboard, take that dashboard, remove that layer of visualization of dashboard, all of a sudden you see a digital twin. That is coming to everybody, and that's the reason I was kind of picking like Baskin Robbins or Auntie Annie's or just a small mom and pop shop, if you will, right? That's thanks to NVIDIA's USD, Universal Scene Designer. That's thanks to all these open source ways of capturing activities and turning these activities into like a real activities, right? So, for example, you can simulate. I think you talked about the Kroger simulation, where Kroger was simulating what happens if they remove one counter and how many bags can a person hold walking out of a place. All kinds of simulations just to say like what slows down the lines, right? So those are all happening with large language model, right? Instantaneously, right? So these are things that you can visualize, but think beyond just visualization, right? You're able to articulate things that previously would have said, yeah, it would have taken us 6 or 7 months to gather those data. But
Yeah.
with large language model, we can create the scenario, we can visualize them, we can feed a reference model through APIs. All is happening because of how many open source tools we have and how we don't know about these tools because we're so bogged down by business intelligence as it was 10 years ago. It's not really changing. But I think what's going to really take people back a little is how NVIDIA is creating a digital twin of this whole planet, of the Earth.
Yeah. I mean,
That means every single grid coordinate locations is going to be available for somebody to use as an open source.
yeah.
You
Well,
don't know what a digital
cesium.
twin of your house looks like? Well, now you can have one.
Yeah. Well, cesium's gotten pretty close with that. I mean, they use they use the Google Street Maps data for some of their stuff, where you can, it's like going in Google Maps, except you can render it in 3D.
Right.
You can hop in there and take a look at whatever you want.
Take a
Some
look
of
at
it's a little bit
what.
old, but
Yeah. Yeah. And
but
it's going to be mix and match, right?
yeah. And the thing you brought up with the cameras and watching a line grow or shrink, that kind of got the gears going in my head, where I'm like, oh yeah, you could have sort of, you've turned your dashboard into a physical space, or at least a digital rendering of a physical space, right? Where I could be just watching the bar graphs, but at the same time see avatars of people in line. So you can say, what is it? Yeah, okay, we had 50 people in the store at 3 p.m. Okay. But then you could look at that physically and say, oh, wow, if there's 50 people in here, it's really crowded. People are at the door. So people are just going to walk by because it's too crowded. Well, okay, let's pause at 3 p.m.
Right.
and add another worker here at 3 p.m. and see what that does to that line if there's two people working there instead of just our one guy. And then let's run that simulation. That's the kind of point you could get to with digital twin.
That's right.
If you do it right and you incorporate some of these LLMs, where you can maybe even just say, okay, add one more add one more teller
Yeah.
at our bank, and see how much quicker we can get people in and out and do their deposits, right?
Yeah.
Because we know, based on just our numbers, this is happening. But when I physically stop and look at it, now I'm seeing it's an issue, and I'm going to try and resolve it.
You know, to this point, if anybody's interested, they can go to YouTube and type in Jim Cramer from CNBC and NVIDIA demo using AR VR goggle by the Apple, which is the Apple's, what is the
Vision Pro.
Apple's name? What's it called?
The Vision Pro.
Vision Pro. And he's looking at under the car, under the hood of the car, to look at the engine and look at the pistons. And he's doing it all in AR VR as he's speaking into the AR VR goggle. Right. So he's telling the Vision Pro, like, hey, I'm standing right here. Show me what's under the hood. Pop the engine and let's go inside the engine. Let's go see what the piston looks like. Let's go under in around the engine. Right. All's happening in real time. But, you know, that's just going in deep. But you zoom out a little bit more, you can say, well, I'm standing here in front of my SUV that I want to buy, but I actually want to see it, what it would look like in Italian Riviera, right? I think that's one of the examples that they use. It's like, it's not in a car dealership anymore. It's actually in Italy somewhere, very nice scenery background. I want to stand in front of my car and watch the car. Yep.
Take a selfie with it.
I'm watching the car in Italy for some reason, right? You just have the endless potential, but it's as limited as the data that you feed it and your data's ability to perform these tasks that you're asking it for, right? So I think that kind of takes us into, you know, we've been discussing what, how of digital twin, but now we have to talk about why of digital twin, right? Because a lot of the conversations about digital twin kind of gets like sort of scraped at this point, right? They say, well, there's lots of data need for that. Well, if you talked about digital twin 5 years ago, and you didn't mention NVIDIA that much, because NVIDIA was doing something very amazing back in 2020 that nobody else was doing. But now that Bentley, Siemens, GE, Microsoft, Apple, everybody is in this digital twin space, you got lots of these NVIDIA things that NVIDIA mastered and NVIDIA has given to everybody else. And the availability is much higher. So what used to be say like, oh, okay, how would you fix that data problem? Well, I think you're going to have lots of difficulty, but there's some solutions to that now, right? So I think that's a why part of today, why we need digital twin is far different than what it used to be in 2020 or even in 2015. Because in 2015, I was using geospatial data for recommender system to point people to where they need to go eat based on their previous historical habit, right? And point them towards a specific type of mom and pop shop businesses, right? Yeah, other than database, we had no other access to any visualization because those visualization will cost money, right? Today, those visualization, like I said, digital twin of the planet Earth, open source to you, so that way you can build a digital twin of your house if you like. All you have to do is know how to write English or write some prompt into your screen,
Yeah,
right?
exactly.
It's that simple. Take some of your picture, all of a sudden you have digital twin that's augmenting every picture you feed into it and say, yeah, I figured out what your house looks like actually. Tell me if I got it right or wrong, right? This kind of capabilities 15 years, 10 back in 2015 was almost impossible. Heard of. You could dream about it. You heard a lot about other companies doing it, but today in 2025, NVIDIA is allowing this to happen. And that's the why part of why you need to have digital twin today, because no matter what AI you do, under the hood of digital twin, there's three components of data that you have to know. And if you can figure out how that pipeline goes from where the data is and where your system is, you have digital twin that you will build and build to maturity over 6 months. I have no doubt about it. 6 months. Build to maturity, as in like from day one to build to maturity, that everybody's like, what did we do before this one? you know? But I will let you speak on that because that's my confidence because I went through emotional intelligence and so many other things back in 2020 as well. But yeah, I think it's very possible to mature it in a very short period of time.
Oh yeah, with all the open source tech that's out there, that there's so many things that are 90% built for you, right? Like these days, like Unreal Engine, it's free, kind of. It's free to a point. If you make too much money off of it, they'll skim some off the top. But um, actually, I don't think that applies to this sort of application of it. They really are a game engine,
That's right.
and they just want to charge you if you sell games. So uh, we've sort of we've skirted that rule for a while. But anyway, there's all of these resources now where anyone can download Cesium, anyone can download Unreal. The hardware, depending on where you're going with the hardware, is a different story. But um, I don't know where I'm going with this. Hold on, let's do a pause. Let's do a pause there because I don't know where I'm going with that.
You can start anywhere you want and cut it up. And, yeah.
Um, I'm trying to think of what a good kind of.
So I think where you're going with that, um, because you have access to these information, like 90%, 10% is what you have to do. So 10% of the information you have to structure it for yourself.
Yeah,
And that's what takes the longest because these informations that you have might not be compatible with what you will have from outside coming in.
yeah, yeah,
And so once you merge those data, what you will see is inconsistency. So when I say maturity within 6 months is because you have to monitor and observe this data. Let's call it a sandbox maybe, or a production environment where you just have to keep an eye on it for 6 months. And all of a sudden it's able to do its trick as much as you ask it to. Right? But you incrementally can grow it, incrementally add more features to it. But at the same time, if it's a business process, how do you articulate the historical data to it, train it in-house? And if you train it in-house without ever releasing it in production, you can actually visualize how good it'll be in production because you're using a historical data, which doesn't harm your business process at all, right?
mm,
You don't have to deploy anything. You can just simulate it, simulate using your historical data, your archive data.
yeah. So you put it much better than I did.
And okay, so I think that's where it gets down to the why part of it is because now you can do so much with data that previously you weren't able to,
Yeah,
right? You can process the data. You can process the data from where the data is to where it needs to be, but there's a lot of the shortcuts that you can take, right? So the pipeline is not a squiggly line. It's more like if I have the data, I know it. If I don't, I'll just live without it. And how do I live without it? Well, I'll let ChatGPT generate those data for me. So if I don't have the image, I let ChatGPT create those deep fake images for me.
hmm
If I don't have the text for it, I let ChatGPT fill in the text for me, right? Or if you're looking at it from the record perspective, you're using Power BI as one of your background for the dashboard. You tell Power BI, fill in those informations that's missing anyway. Just see what happens. Well, I filled it in, but there's billion records now. Okay, so run a scenario and tell me where can the deficiency might be because you know where you filled in the data, right? Like those imputed data, right? So the scenarios are endless, but the variable is what you have to monitor for the next 6 months, right? You can deploy it as fast as you like, or not deploy it, but always have to monitor it for a lengthy period of time because your variable will catch up to you if you don't monitor it over time. Right? I'll just leave it at that. So you can start all over again. That's fine.
Sure. Yeah, let me start that one over again. I'll give it a pause so it.
Yeah.
How long of a pause do I need?
They're fine. You're good. I just need a little bit of break. That's all.
Okay.
Whenever you're ready.
Yeah,
You go.
sorry. I heard a noise and I was like, I hope that's not a child that's woken up. Okay. So these days we're kind of in a position where a lot of the oh my God, sorry.
Man, I understand. It's 12 o'clock at midnight.
Yeah, 12 o'clock
We
at
gotta do what
midnight.
we gotta do to sell our shit, right?
Yeah. All right, give me a second.
So this piece here you can articulate because this one I will add to that Eventbrite with digital twin workshop.
Mhm.
There's a video spot there as well. So when people land there, they can click on the video, they can hear about why this workshop is important. There's images and there's videos. So you can start there, like, talk about education, why you need to be educated first, and talk about the shortcuts that you have to understand in order to say, yeah, you can do digital twin, but take a year and a half, or you can do digital twin day and a half. You might come to a different conclusion. Things of that nature. Kind of create that urgency of like, you need to be educated. You need to
Yeah.
get started with the right people, sort of.
Yeah. Okay, makes sense.
Yeah.
Just trying to figure out how to start. I'm trying to remember what you had said that I'm piggybacking off of that you said like 15 minutes
Yeah.
ago
We'll
now.
just talk about the why of digital
Yeah.
twin, kind of
Yeah.
go into the theory of it, why it's important, and what do you think will be the impact of it in the future.
Yeah. Mm-hmm.
Or you can talk about a use case, a case study that you've been part of that has grown into maturity, right? Like,
Yeah.
I did this, day one, it was like this, but day 30, day 90,
Yeah. I'm really stuck on how I start, like my first sentence. You know what I mean? Like I know all of the things after that, but I'm like, okay, what's the first words to say to get me going?
Yeah.
Um,
Yeah. So talk about like things that are moving fast,
mhm.
right? Things are moving fast, and adoption is kind of is chaotic, but it smoothens out over time because everybody sees the value in it.
Mhm.
So you can say like added value or value proposition here is like this.
Okay.
Yeah.
Okay.
Yeah.
So the important thing is that now digital twin, the implementation of it has gotten a lot faster, at least on the kind of visual side of it, because folks like NVIDIA, people at Bentley and Cesium have created a lot of these tools that do 90% of it for you, right? So you're at that 90% where you have a lot of this visual data, you have a lot of the immersive tech that already exists and has been generated. So then your now 10% is feeding it your, business relevant data to where, anyone can go into Google Maps and look at their house. But now what you can do as a business is add value to that with using your existing data to where I can say, all right, now I know what this, damn it. I got lost in something there. Uh, I don't know why I'm suddenly tongue-tied about this.
Well, you're bringing your data,
Mhm.
your own data, and you're merging it, right? That's the theory you're trying to prove.
Yeah, to where it's like the tools exist to make it, and you can make it very quickly. But what makes it actually valuable is the data
Right.
and how you can feed that data into the digital twin, or
Yeah.
even go back and forth.
Yeah. Yeah.
So
So I think the way you articulated it is that if you have data at rest and data in motion and data in use, these are the three components that if you look at it, you have to create a feedback loop for it. So right
mhm,
now, what you see is a lot of data at rest, data in motion, data in use, and start again from data at rest, data in motion, data in use. I'm using that as a sort of formula for people to understand that the engine under the digital twin, the way it is today, the way it's not so effective is that it stops and starts again, stops and starts again, rather than a feedback loop. It is continuously happening. So going back to the example I made about if I had a phone that was existing in real world, but I have a digital twin of it in my laptop, and every time I press a button, whatever button I press in my laptop, my phone starts doing that. That's my digital twin.
mhm.
I have a digital twin of my phone, and considerably, it's every single feature of that phone is in that laptop. Now you have no doubt that's a digital twin, but if you had one feature in there, it is still digital twin. It's just that it's not configured to be everything in your phone, right? So, say for example, you can actually do this right now. You can do many things, like your phone, like your office, your video of yourself, your cybersecurity tools that defends you right against your predators that are trying to attack you. You have all sorts of ways that you can do digital twin, but they don't have that continuous feedback loop, and that's difficult. If you're able to do that piece, that means you can do that with almost everything else in your ecosystem of, say, sensors, business processes, customer interaction, day-to-day activity, right? You can do so many things, but they all require that data at rest, data in motion, data in use, and feedback loop to say whatever data I just used, it feeds into it again and processes that data and gets it to start showing me things that otherwise previously wasn't visible to me, right? Um, so I'll go back to the example of cameras one more time. The security camera. The security camera right now, the way it looks, it sees things and you have to see it for yourself and say, I just seen it. And then, you have to make those things work on your behalf, right? Um, what if you could have early detection? What if you could find insights in real time? Well, security camera doesn't do that. Why doesn't it do it? Because of this data at rest, which is whatever the camera is looking at, data in motion, data at use. Data at use, it stops right there. If I seen it and I want to do something about it, that was the data at use. No feedback loop. Nothing has changed. Next time something happens, I still have to do the same thing. I have to look at the video feed, right? So now, because of AI, that video feed creates a feedback loop. As the real information comes in, you're training the system to say, next time this happens, this is the reaction you should have. So a good example of it is that I did a emotional intelligence piece. So this was the kind of use case that we always talked about. Is so the fact is like if a guy walks into the bank and he has a weapon on him and he's wearing a cap, you should not put the alarm on every time because that's the guy that's coming in to pick up the money legally from the bank because these guys carry guns. But if you have a guy who's walking in with AK-47 wearing a hat and glasses, that's AK-47. You should know that. That's a security camera that's able to detect this information in real time. People don't call that digital twin. They will just call it an AI system. But if you think
Wait,
about
so
it, what
Sorry,
it,
hold on. My kid's crying. Sorry.
I'm in pause
Sorry.
again. Yeah.
Sorry. 1 minute. Ding.
Put the monster, the beast into work. Yeah, so data is a beast, right? There's no doubt about it. Data is a beast. Data has always been here. It will always be here. But the format, how you can save historical data and put that historical data to use, is what I focus on most of the time. Because there's many ways to go about digital twin, but guy like me will not care about how you process that data, because I can process that data in 1,000 different ways, right? And it will depend on the use case that you want to use it for. So if you have lots of data and you are good at collecting data, all you have to do is think about like what it is that you already do and how it is that you will create your digital twin, personalized and tailored for your business use case, right? So data is a beast, but you're dealing with data as we speak because you have business intelligence. If you have business intelligence, digital twin is just your next best step, because you want to integrate an AI portfolio, which will serve your data portfolio. But that AI portfolio, if you put it inside a digital twin, guess what you get to do with that? You get to show it off to people, right? So you put your data to work. When you put your data to work, you can take it to the bank, you can take it to your lawyer, a lawyer for exit purposes, right? The succession purposes. Like you're about to hand over this business to somebody else. You can show off all your business processes to somebody without using a dashboard. You can show off to thousands of people the same picture. Everybody will get the idea that, yep, your data actually works just the way you said it would, right? You want to take it to your tax authorities, like accountant. You want to show off your insurance companies, your proficiency in business, and how low risk your business is. All sorts of things you have to explain. You can do that with digital twin, and that's putting your data to work, putting your business intelligence to work. Very high level of use of digital twin, because you can start very small and then grow it to that big of a use case where your majority of your ecosystem is covered inside a digital twin, and maybe not so much of your IPs, right? You keep the IPs to the bay. Maybe you do a separate thing for your IP, but huge use case for digital twin and specifically for your data. Put your data
Yeah.
to work.
Yeah, I like what you said there with you're putting your data to work with these digital twins, right? Because you can not only be feeding data into the digital twin to generate it, uh, using that data you have to create physical simulations, to create visuals around it, but you can then generate more data from that digital twin to feed back and train ML models, create more data, create even more, you know, information you can work from to improve your business or anything like that. So it creates sort of a feedback loop, like we've mentioned before, in that you're putting your data in and you're getting more data out,
Right.
and you're improving the structure of what you're building as you go. Like the digital twin can just get better from its own data that it feeds into itself in this feedback loop. So you
Yeah.
can start with just, like we said at the beginning, something as simple as a 3D model with a few camera sensors. And as it matures, based on the data you feed it and it feeds back to you, you can create a mature digital twin that gives you some incredibly useful data
Right.
in a very short period of time.
Yeah. It's a good way to invest into data and getting more out of that investment, right? Your
Yeah,
return on investment.
yeah,
But key part of it that I always bring up is return on data. Why are you spending that much money on data where you could just spend it on, maybe, I don't know, paying somebody's salary, right? Like people can do the same for you if you just let them. But you want to automate things and you want to release some of those repeatable, redundant, and dangerous tasks away from human hands and outsource it to a automated system, be it RPA, be it robotics, right? Humanoid robots. The world that we're moving into right now will have lots of humanoid robots.
mhm,
So when you want to outsource anything to AI, well, can you outsource it to an AI? Yes, you can. Can you outsource it to a human and a robot? Two different questions, two different answers, two different output, right? So when you develop a good return on data for yourself, it works for AI. It should also work for human and robots, because core component of, if you see some of those NVIDIA's activities, is what they're doing is that they're training through a simulation without actually training in physical space.
Yeah,
When you
synthetic
see
data.
NVIDIA has all these robots are not actually trained physically using
Hmm.
their motor parts, right? They're brand spanking new. You rip them off the box, and you open up the hard drive on their head and say, "Run this simulation and walk around like you're a funny man or something like that," right? All of a sudden, it can take that personality of funny man and just ride around. But the reason I pick funny man is to be just like very obscure about it, right? Because you can tell a robot just to say, you pick things up and you drop them off. You pick things up and you drop them off. Well, we do that without thinking too much about it. But for a robot to do that on day one without ever being trained on it, well, all it takes is a physical memory of that simulation, right? So what it has to do is identify an object and say that object is 5 ton. No human will pick that up. Let me go pick that up and put it where it's supposed to go. And I know that because I have geospatial data built into me. I know exactly where that 5 ton is supposed to be because I'm very aware of the business process. It goes on and on and on. But you've trained it for an AI camera system, and now that camera system can turn into a humanoid robot, and humanoid robots will use a computer vision like camera systems with his eyes and say, "Yeah, I can identify the same thing AI can. All I needed was the AI to tell me what to do next because I have the motor cortex function or tactile senses of that function to be able to perform this task in day one." Right. So return on data, return on investment, return on everything you're trying to do with digital twin. It can go in many different ways, but ultimately, put your data to work. Get that feedback loop going for your data. Right now, it's a half baked data. I would say it doesn't have the
Yeah,
full feedback loop. It
yeah,
starts, it stops, and starts again and stops again. Right? It doesn't have that full feedback.
yeah. I really like that term, return on data, because we're all putting a lot into data. We all have a lot of data, and now is the time to do something with it. And
Right.
I think a digital twin is a great way to use some of that data because of the thousands of applications of it, like one you just even mentioned of using a digital twin to train the next product, right? You might not have started as a robotics company, but you're going into that field, and you have all this data that you could train a robot with. There's endless possibilities with all this data we have,
Yeah.
and getting a return on it is something that a digital twin can really help you with.
Yeah. Yeah. Think of it from dashboard and beyond, because if you look at NVIDIA's training ground, the dojo where they train the robots, these robots, if it wasn't for digital twin, it would have taken 10 years to train them.
Yeah.
But because of how much processing power NVIDIA has, they're able to train these systems within 10 days.
Yeah, because to simplify it, right, instead of running 5,000 robots through my physical warehouse
Yeah,
for, hundreds and hundreds of hours
that's
for
right.
them to actually get trained on this, I
Yeah,
can run all those simulations at the same time on a digital twin
yeah,
of this warehouse that I've built, right? To where they're running around a video game basically and learning it that way instead of me having to build the robot, bring it over there, have it scan everything, or even us going doing LiDAR scans or whatever else.
right.
Nope, don't need to do it. We can just have them play a video game for a couple hours, thousands and thousands of times over in a matter of a few hours, and get all that data.
The best conversation I've ever heard somebody have, which I wasn't there, but once I heard it, it just made me feel so much more comfortable. Because when we visualize things in our head, in physical space, we think the robots will have to look like us and do the work just like we do. But the way we do work today is very inefficient.
Mm.
So when you have to do it in a simulated digital twin space, you take a physical space that you're working all day long, and now you tell a large language model to create a robot that will work in that space. That robot doesn't have two legs.
Yeah,
It doesn't even have wheels on it. It literally has two arms and it's stationary. And it does all this work because you can actually save by having stationary arms in every part of your
mm,
office space, rather, oh, not office space, let's call it a warehouse. Let's use the example of warehouse. nothing moves actually. It's just the arms, right? It'll be just like a manufacturing shop floor, but an inventory, right? A
Yeah.
warehouse,
Yeah.
and everything is moving because there's just arms. That's all you needed. But to make those arms is far more cheaper because those arms probably will require more maintenance. But instead of rebuilding a whole robot, you throw away the arms and replace the new arms with it.
Yeah.
And these things are not made out of steel or aluminum; they're made out of almost plastic, right? Well, because the digital twin system can look at the activity of the humans and say all he's doing is using his tactile senses to figure out how to pick something up without dropping it and not squeezing it too hard.
Yeah.
You don't
And
need a
checking and
robot
making
eye
sure
for
it
that.
grabbed the right thing, which you got computer vision. It can know if it got the right thing out of the warehouse, it got the right widget. It can see it with its camera and say, oh, no, that's the wrong thing. That should be on this shelf. I'll grab this thing instead. So yeah, we're at that point where we have the data to train something to do that.
Right.
Uh, it's just about someone kind of taking that opportunity and finding out how to do it.
Yeah. So, in our workshops, we always talk about the fact that it's not about the use case; it's about the questions that you're asking.
Mhm.
Because if you look for a use case, I can lead you to thousands of use cases, but none of them are almost possible for interoperability because you have to drop a lot of them for interoperability purposes. But if you ask questions and if you're able to ask the right type of questions, like AI does, AI asks the right questions all the time. I find that more fascinating about AI than just answers, because I want AI to just like start thinking about like, hey, I'm trying to brainstorm this. What questions do I need to ask? All of a sudden, it asks questions that I'm like, I wasn't even thinking about that, right? So that kind of goes back to the scenario I was describing, where, you know, do we need a robot with two legs? Maybe not. Maybe we just need a two arms that can skate on things. I don't know.
Yeah,
It'll just look
it's
weird. It
interesting.
won't look nice, but it will do the work that you're trying to get done. You know.
Yeah,
Um,
we have maybe we have sort of a pop culture idea of what a robot is, and it clouds the way we think about things. And
exactly.
that's, I mean, that goes into so much of our technology that we build. Is we have a pop culture idea of what this thing is. We have some sort of stereotype in our mind through media or anything else about what this futuristic thing is. And sometimes you need to get that out of your head.
Yeah, hell from Space Odyssey, right?
Exactly.
Um,
Yeah.
that's a robot. That's a
Yeah.
system. The Tesla cars are robot, right? It's a full
Yeah.
self-driving car. It literally doesn't have any arms, but it's literally steering everything. The whole car is a robot, but we
Yeah.
don't call it a robot. We call it a full self-driving car. But these days they're so worried about people's perception of it. They want to put a robot on the driver's seat and have that robot drive the robot. But all right,
Robots driving robots.
robot drive. But I think this is the part of the conversation where we have to just say, "Let's get it done, man. Let's do it." But
If
great,
you don't,
great,
someone else
great
will.
conversation here.
Yeah, I
So,
enjoyed it. Yeah, we went down some down a few paths that got me thinking.
yeah, yeah. Well, that's what we do, right? We
Yeah.
have ways to brainstorm things and ask questions about topics that we know. Because you have a domain expertise, I have my domain expertise. When you bring this domain expertise together, all of a sudden you start mashing things together. It's like, yeah, I literally can do it. I just didn't know I was able to do that, right? And that's the beauty of a workshop where team alignment happens. Teams are able to see eye to eye on things and to say, this is the baseline. If we can get this baseline done, we can do so many other things on top of it, right? Let's build that foundation. Everybody's on the same foundation. Everybody can see eye to eye. We can communicate with each other. A lot of the organizations are asking for this is because they have seen previously how teams are not able to execute on these promises, right? They know it's possible. It's just that end goal wasn't met and not everybody knew what the end goal was, right? Because the end goal in MLOps, not to be funnier at all, that's where the MLOps actually starts. Once you deliver your data and AI, that's where your work actually starts, because that's when you have to do version iterations. You need to improve that MLOps procedures for the next time. So many things, and MLOps starts at the end stage, right? Um, so I'm very happy and excited that we'll be able to do this workshop where you bring your domain expertise and I bring my domain expertise and we chop it up.